Hello friends, welcome to my channel. Let's have a look at problem 2375. Construct smallest number from DI string. So this is a newly appeared problem. So in this video, we're going to share two solutions. So the first one is based on directly reversing, and the second one is going to use the stack abstract data structure. So let's first look at the statement of the problem. So we are given a zero-index string called pattern of length n, consisting of characters I meaning increasing and d meaning decreasing. So a zero-index string num of length n plus 1 is created using the following conditions. So the num consists of the digits from 1 to 9, where each digit is used at most once. So if pattern I equals character I, then it means nums I is less than nums I plus 1. And if the pattern I equals character D, it means nums I is larger than nums I plus 1. So we are required to return the lexical smallest possible string num that meets the condition. So here are two examples. So in example 1, so the return is 1, 2, 3. And 5, 4, and then 9, 8, 7, 6, right? So it satisfies the condition. So let's look at the constraints on this problem. First, the length of the pattern string is bounded above by 8. And the reason is that we have only 9 character, right? So we're going, as specified in the problem, so we're going to use digits 1 up to 9. So at most. The secondly, pattern consists of only letters I and D, right? So as in the statement. So with that said, let's look at the analysis. So here we're going to present two solutions. The first solution is we do the directly reversing after we analyze the problem. And the second method is based on a stack data structure. So this problem actually provides a good application for practicing the stack abstract data structure. So first, let's make some simple observations. First, if the length of pattern is n, then we need to use n plus 1 digits. For example, 1, 2, up to n plus 1, right? So secondly, when we see a transition from D to I, we need to do the reversing. So in order to absorb the case that the pattern ends at D, so we imagine that there's an I in the tail. So this just plays the role of auxiliary effects. So here I'm going to give you a walkthrough for example 1 and example 2. So the pattern string in example 1 actually has length 8. So we're going to use digits 1 up to 9, all the digits. So here is a pattern. So then imagine that we have a I at the tail, and the first row here is the corresponding index, and here is the digits. So first, so we notice that from 3 to 4, so there is a transition from D to I. Then we keep this 1 to 3 unchanged, and then we switch or reverse the corresponding segment from index 3 and ending at index 4. So that is, we switch 4, 5 to 5, 4. So then next we see a transition. So from here, D to I. Then we're going to switch the beginning of this D and the ending of this D is before this 8, right? So we're going to switch reverse 6, 7, 8, 9. So we're going to change it to be 9, 8, 7, 6 in order to meet this decreasing condition. So then afterwards, we're going to get 1, 2, 3, and 4, 5, and 9, 8, 7, 6. So that's example 1. So this is the corresponding return. And then let's look at example 2. So the pattern DDD has length 3. So we shall use digits 1, 2, 3, 4, right? So this way we make the final result or the final string as small as possible in lexical order. So the pattern is like this, DDD. So we can think of or imagine there's an I at the tail. So this is the corresponding digits. So we see here, this is the beginning of the D, and before 4, this is the ending of the D, or the transition place. Then we're going to reverse 1, 2, 3, 4. So we get 4, 3, 2, 1. And then the return is 3, 4, 4, 3, 2, 1. Right? So that's the walkthrough for this 2 examples. So next, let's look at our plan and implementation. So first, we're going to use an implementation that is more verbose. We're going to find the transition indices and then do the reversing, right? So this is a little bit verbose, but it helps us to understand the finer detail. So we shall first do this for details here. And secondly, we're going to give an implementation using the stacked abstract data structure. So this actually is to give us a slightly shorter code. So with that said, let's do the coding. First, I'm going to use directly reversing, right? So for this, I'm going to find the start index and end index for the Ds, and then we do the switch in the corresponding segment. So first, I'm going to say starts. I'm going to initialize starts and ends to store the corresponding starts and end position for each contiguous piece of Ds. And then we are going to do a iteration, right? So let's regard this as step 1. So find starts and ends of consecutive Ds. So, and the second step is to do the reversing, right? So for this, let's do an scan of the pattern. So for I and the character in enumerate. So I'm going to add this pattern with a tail. Let's call it I, just to make it the writing easy. So then we're going to see a special case if I equals 0, right? So if the character equals D, right? So we're going to add this I to the starts. So starts append, so I. So this one case. Another case is when I does not equals to 0. So we can look at the current character, and also we can look at its previous one, right? So in this case, if character equals D and pattern I minus 1 does not equals D. So this means that the current index is a start of consecutive Ds. So we're going to append start with the current index. Let's put this I in the parentheses. So this is one case. Another case, if character equals I and pattern previous does not equals I. It means, so the D ends before this I. So here let's add this I to the ends. So technically we can also append I minus 1, but let's add n here, use this convention. So with that said, actually we can get the corresponding starts and ends for consecutive Ds. So that's the first part. So actually, if we like, we can print out the starts and the ends for understanding. So later, let's do it. So now let's prepare the result, do the reversing. So first, let me track the pattern length. So if the pattern has length n, we're going to use n plus 1 digits. So the auxiliary for this will be list range. So we're going to from 1, then n plus 2, right? Because we are going to have n plus 1 digits. So with that said, so we're going to do the reversing. So for start and end in zip, starts and ends. And then what we're going to do is that we're going to reverse this one. So notice that end is actually the beginning of an I. So so it means that a start, a consecutive D ends right before the end index, right? So that's the correct segment. We need to do the reversing. So we're going to set it to be start. So here actually, if it should be I plus 1, I guess. So the character equals I, and character I minus 1 does not equal to I, right? So here let's change it to be n plus 1. So we're going to reverse this part. So after that, actually we can return the result. So what we're going to do here, actually we can do something like this. John. So string I for I in an ox, right? So let's do a special case check. So yeah, it passes the first example, right? So if you are confusing about the indices, so you can look at here, right? So for example, this one. So the start of this D is 4. The index is 3, and then we need to switch these two, index 3 and 4, right? So we need to get the index for 5. So for convenience, let's maybe print out this starts and print out this ends, so that we can know the specific place. So for example, here is 3, and this is 0, 1, 2, 3, 4, 5, right? So we need to switch. No, here start is 3, and the corresponding end is 4. So 3 and 4. We need to switch this piece starting from 3 and ending at 4. So therefore we need to write start and end plus 1, because end plus 1 is not included. So that's a special case check. Now let's comment this out and then do a generic case check. Yeah, it passes all the case. So as we mentioned, this is the first version of solution we want to present. So now let's present another solution. So let's copy this function signature and then put it here, and let's call this one v1. So v1 actually is a little bit verbose, or very, in some sense, brute force. But for this problem, it helps us to add the detail. So next, we're going to use stack data structure to mimic the above procedure, actually. So here, let me make some annotation. So we're going to use stack abstract data structure. So for this, actually, once we add the above solution, so this actually is straightforward. First, we're going to initialize a result list, and then we're going to initialize a stack. So the stack will store the digits. So we're going to do this. So for I and character in enumerate. So the pattern. So again, we're going to use imagine a I in the end, right? So then, because we're going to use digits from 1 up to 9 at most, so we're going to use the start index to be 1, right, in the enumerate function. So for this, once we examine a character, so we're going to add that character to the string, to the stack. So this problem requires us to return string, so we can actually change this tab here. This is a standard. Then if we see a character that is I, so in other words, so we locate a transition, right, from D to I. So then actually we need to include this current string corresponding to the number I for the reverse. So once we look at this, and then we're going to add the result. So with the reverse of this stack, right? So you can think of this DDD, right? So if we met 4, then we're going to this is actually the current stack status. Then we're going to reverse to be 4, 3, 2, 1, and then this is the case. So after this, what we want to do, that is we reset that this one, and then if we meet another I, consecutive I is just reverse a single element stack. That's the same element, right? So after this, actually, so we're ready to return. So let's again using the John. So notice that in this result, what we stored actually is the substrings with not integer, right? We can directly do the John. So result. So that's actually the second solution. Let's do a special case check. So it passes the first example. Now let's do a generic case check. Yeah, it passes the all the cases. So here a technical thing is that if we initialize the result to be empty, and here actually we can do the same like John. And then we can directly return the result. So yeah, it's just a very tiny tweaking. So it's no essential. Personally, I like this this one. So because we just need to use one John at the very end. So yeah, let's character string I. So yeah, so we need to use John here. So I guess with all the cases passed, so that's about it for these two solution formats and for this video. Thank you very much.